Alright, time for our last college algebra lesson. Fortunately, it's another easy one if you've been paying attention and following the videos and using the matrix calculator online. This should also be very simple. So, we are going to solve systems again. So, like last time, we solved systems by using inverse matrices. This time, we're going to solve systems by using determinants of a matrix. So, let's talk about determinants of a matrix. So, if you remember finding the inverse matrix, remember that setup, finding the inverse matrix, where we had of just the 2 by 2 matrix, we had A is equal to A, B, C, D, and the inverse matrix was equal to 1 over A times D minus B times C. That's not a C. Times, and then we flipped everything around, so it was D, A, B. Right. This right here, this bottom part right here, determinant of a matrix. So that's of a 2 by 2 matrix anyway. That's how we find the determinant of a 2 by 2 matrix. So a determinant of matrix A is equal to A times D minus B times C. Right, so it's real easy to do a determinant of a 2 by 2 matrix. All right, so find the determinant of each of these. We'll go ahead and do that. It's not hard to do this by hand. So again, it's basically multiply the diagonals. So negative 2 times 1, negative 2 times 1, minus 5 times 3. So negative 2 minus 15 equals negative 17. Right? Same thing. Negative 3 times negative 1 minus 2 times 4, 3 minus 8, negative 5. All right. So, that's really it for a 2 by 2 matrix. Find a determinant pretty easily. Right now, so let's look at how to solve a 2 by 2 system. Now, this is going to require the creation of 3 matrices. Right. I'm not going to do any of this. Okay, this is a kind of a waste of time. I'm going to do things differently. Okay, so just take my notes real quick. All right, we are going to have matrix A. Let's say matrix D. Okay. And then we're going to have matrix X and matrix Y. Now, matrix D, it uses only the coefficients. Okay, so it's just a 2 by 2 of the coefficients. So it's going to be 2, negative 3, and then 1, 2. Right. Now, what matrix X is going to do is, remember, we're going to take matrix D, so 2, negative 3. Don't write this down until you see what I'm doing. 1, 2. So you have your coefficients of X, your coefficients of Y. So what a matrix X is going to do is it's going to replace the coefficients of X with the solutions. So instead of 2, we're going to have negative 11. Instead of 1, we're going to have 12. So you replace your X column gets replaced. Now matrix Y, what do you think is going to happen? If you said replace your Y column this time, you're correct. So your Y column gets replaced. So we have 2, 1 now, but instead of negative 3, 2, we're going to take our solutions, negative 11, 12. And that is how we create the 3 matrices. So Cramer's rule requires creating 3 matrices and then using the determinants. Okay, so X is equal to the determinant of X over the determinant of D, and Y is equal to the determinant of Y over the determinant. That's weird writing there. Determinant of t. So we're going to go ahead and multiply. So 2 times 2 minus a negative 3 times 1. It becomes 4 minus a negative 3, 7. And then we have negative 11 times 2 minus 12 times negative 3 gives you negative 22 minus negative 36, which is 14. Two negatives become positive. And then we have 24 minus negative 11. Again becomes, well, let me write that out so you don't see where I'm from. So 2 times 12 minus negative 11 times 1. So it gives you 24 plus 11, 35. So determinant of x was 14 over 7, which gives you 2. And determinant of y was 35 over 7. 7, which gives you 5. So my answer is 2, 5. And you can plug it in and see it works. All right, 2 plus 2 times 5 is 12. 2 times 2 is 4 minus 3 times 5. So 4 minus 15 is negative 11. There we go. This is our last way we're going to be solving 2x2 systems of equations by using Cramer's rule. Now, I love Cramer's rule. Okay, it's my favorite way to solve matrices. I think it's the easiest. Now, here's another thing. Remember last class we showed you how to do inverse matrices on the matrix calculator. I'm going to go back here. Back here, matrix calculator. I can put in my matrices. Okay. So we have matrix A was, what was it? 2, 1, and then negative 3, 2. 3, 2. It says find the determinant right here. Determinant 7. Now all I do is change this to negative 11 and 12. Find the determinant. 14. Change this to negative 11, this to 12, this back to 2 and 1. Find the determinant. 35. See how easy that is? The only thing you really have to be able to do in this chapter 6.5 is to be able to create the 3 different matrices. Is to know how to set them up. So this is determinant D, determinant this is X, and this is Y. So this is matrix D, matrix X, matrix Y. If you can create the matrices, you can easily find the determinants. Now, I'm going to really suggest, because what's after this, I think it's going to get harder. You have 3x3 matrix. It is a lot more work to find the determinant 3x3 matrix. In fact, I don't even want to go through it because I don't want to waste your time with it. I'm just going to say do it on the calculator. I would really suggest doing this on the calculator. So what I'm going to do, because this is how you would do it, by the way, set this up. If you really want to see it, this is what you would do to find the determinant of the following matrix. We'll do 1 just so you see how it's done. And I'll do it on the calculator to see how it's done so much easier. So what we're going to do is first rewrite the first 2 columns. So we have column 1, 2, and 3. And I'm going to rewrite 1 and 2 again. So negative 2, 1, 3, and then 1, negative 1, 1. So what I'm going to do is I'm going to multiply the downward diagonals. Multiply and add downward diagonal. All right. That means multiplying these together. So negative 2 times negative 1 times 0 is 0. Plus 1 times negative 2 times 3, which gives you negative 6. And then 0 times that is 0. So we get. Then I'm going to do the same thing with the upward diagonals. So multiply upward. So, negative 3 times 3 times negative 1 times 0 is 0, plus 1 times negative 2 times negative 2 is 4, and then 0 times that is gives you 4. So, and what we're going to do is we're going to do the first one, right? So it's going to be downward minus upward. So it's going to be that first one minus the second one. Negative 6 minus 4, negative 10. So let's set this up on the matrix calculator. Show you how much that way. So I should get negative 10. That's correct. Negative 2. Negative 2. 1, negative 1. 2. Negative 2. Have 3, 1, 0. And find the determinant. Negative 10. Yeah, that's the triangles rule, which is fine. If you don't do that, that's what we did anyway. Downward diagonal. If we extend this out, downward diagonal. Extend these out, downward diagonal, and then upward diagonal. Extend this out, upward diagonal. Extend it out, upward diagonal. That's what we end up doing. So, oh, that's what we did. Okay, rule of Saris is what it's called apparently. Still the triangle rule, kind of the same thing. Okay, really like how this says. Let me see what this is. Wow, that looks like a pain. I want to do that. This I've seen. Okay, it's still a bit of a pain. So I can do that. All right. Yeah, that's how we're gonna find determinants. So go back to the PowerPoint. I'm not gonna do this at all. Solving systems again. I'm not gonna, like I said, I'm not gonna do the determinants by hand like I do with this 2x2 because 2x2s are super easy to do by hand. In fact, usually it's easier to do by hand than on a calculator, but you can always use it just to check. So, just like before, you have your determinant D, and then you have your matrix D, your matrix X, matrix Y, matrix Z. For X, you're going to replace your X column with your solutions. Y, replace the Y column with the solutions. And then Z, replace the Z column with. So we want to first set up our three matrices. There are 4 matrices because you have a D, X, and Z. D would just be all the coefficients X, Y, and Z. Change. So negative 2, 1, there's no Z, so 0. 1, negative 1, negative 2. 3, 1, 0. Does this look familiar? I think this is the matrix we just saw for. We already know that's negative 10. All right. Then we have matrix X, which replaces the X column with the solutions. So we'll go S. We have 1, 2, 6, 1, negative 1, 0, negative. And then matrix Y, which replaces the Y columns. X, solution Z. Negative 2, 1, 3, 1, 2, 6, 0, negative. And then matrix Z, which gives us X, Y solutions. Negative 2, 1, 3, 1, negative 6. So I'm going to put these in the calculator, in the matrix calculator. Just to find. We already know that's negative 10, so I have to here it is. So yeah, we already know that's 10. So I'm going to replace this with Oh well, if you guys want to play around, go right ahead. I really. Oh, we can move it over. All right. Anyway, so we're into that. So we're gonna do 1. Find the determinant. That's also -10. -10. This to be 1, 6. Negative. Find the determinant. That's -30. The last one. 1, -1. 1, 6. Find determinant. 20. Now, using the Cramer's rule, that x is equal to the determinant of x over the determinant of d. That is -10 over -10, which is 1. Y is equal to the determinant of y over the determinant of d, which is -30 over -10, which is 3. And z is equal to the determinant of z over the determinant d, which is 20 over -10, which is -2. So 1, 3, -2 is this. So there it is. That is everything to this lesson. I'm not going to do any more. Okay, just to show you what your homework is going to be. It's going to be only use Cramer's rule, basically. So this. So I'm going to have you do, let's say, let me write this down before I forget. So I'll have you do, we didn't talk about inconsistent and dependent equations. Okay, let's talk about that real quick. Let's say you do your, bring this up. Let's say you do your Cramer's rule and you find that your determinant that we have, let's say we do our 3 by 3. So 3 by 3, and we have d, x, y, and z, and it is being that the determinant of d is 0. Is 0. Now, if your determinant of your original function is 0, that either means you either have a inconsistent system, which means you have no solutions, or you have an infinite number of solutions, a dependent solution system. So you have infinite solutions. All right. Now, in order to get no solutions, the determinant of x, and determinant of y, and the determinant of z, none of these can equal 0. So none of these will be 0. For infinite solutions, determinant of x, determinant of y, and determinant of z. Or say none of these. At least one of these can't be 0. Okay, so if all of them are 0, like this one, if all of them are 0, this is an infinite solution. Make sure of that before on the PowerPoint. Yeah, if d and all the determinants in the numerators are 0, then it's dependent and there's infinite many. So, and then said, yeah, okay. So at least for no solution, one of these has to be non-zero. For infinite solutions, all 4 determinants have to be 0 for infinite solutions. So if you get the determinant of d's being 0, that means that those are your only choices. Okay. That means if you do x and it's 0, do y and it's 0, but do z and it's not 0, then it is a no solution system. But if you do x, y, and z and they're all 0, it's infinite solutions. All right. Now, I don't know which one's which, so I'm just going to give you a few, and it doesn't matter to me. So let's say I'm going to give you I'll write it down over here. Go away. Done. I'm going to give you, let's say, number 13, 19, and 23. And then 33 and 37. So not many to do. I'm not going to waste your time with this. So just 5 questions. And that's all I want you to do for the homework. Very last homework assignment, college algebra. Now, if you've got the message from before, the only people who have to take the final are those who go in for college credit. Okay, you have to take this final for college credit. And if you do, what's going to happen is for the GCA grade, it'll count as a test replacement grade. It'll just replace your lowest test grade if it is a little higher than your test grade. That happens again. That's for everybody. But for those who take it and they have to take it for the college grade, it's going to count as 20% of your final grade. Only for the SLU course. So that will not show up at GCA. It will only show up on your transcript from SLU. Good luck. Have fun. I'll post that final in a couple weeks. Make sure you get as much homework done as you can, okay?